Okay, so you made it. We've done the first part of knowledge graphs. So looking back, essentially what we did is we created a new data format, these knowledge graphs. And one way to look at it that is as a unifying layer for other data sources that we can build applications on top on. So traditionally, we have all kinds of different formats. You have databases for web-based systems. You might have some spreadsheets, some text documents, maybe some data that is already in graph format. But now we want to be able to build applications, make queries, do reasoning across all of these multiple different sources. And one way to look at knowledge graphs is that they give you a nice way for integrating knowledge from different sources in one single common format. And then we can build various intelligent applications on top of it. For example, these intelligent assistants, these modern chatbots, but also a number of other applications. So another way of looking at it is that we now have this web of data. So this is our common graph format. And next week, we will talk about common vocabularies as well, which integrates all of the existing sources that we have with various connection bridges. So again, in one of the next lectures, I'll briefly show you how you can export a relational database into a graph format. And then based on this knowledge graph format, you can build applications on top of it. And this is something that worked out quite successfully for many applications. So people, well, originally in research, but more and more for the last 15 years, this has become used in industry for reasoning and querying across multiple knowledge sources. A couple of these systems you can try out online. You can see a bit more behind the scenes, what they do, how they do reasoning. We'll talk about some of those more in the upcoming weeks, for example, for all of these existing knowledge bases, knowledge graphs on the web. So one of the best known and one of the most important knowledge graphs is DBpedia. And this was also originally a research project. So I mentioned the idea is that you have a machine readable version of Wikipedia. And originally it was built by looking at only the info boxes because they already have some structure in them. And the newer versions of DBpedia integrate some additional information. But essentially it works with the DBpedia from multiple languages. It processes it and then creates the DBpedia knowledge graph. And you can access the current version online, which is what you've used in the exercises so far. There are a couple of other systems used for various AI challenges, for example, competitions that try to do reasoning, that try to find out information that is used as part of research. For example, Microsoft has a project that's using AI for precision medicine, and part of it is a knowledge graph of scientific publications. I have the link somewhere if you want to look at it further. And with the help of these graphs, these assistants can do more and more challenging tasks. For example, there is a task where you have to answer multiple choice questions. So this is something like you would do in a typical high school challenge. You have some, in this case, biology domain, and then you have to give an answer to a question. And now you want to have an AI that is able to answer questions like this. So obviously, to answer a question like this, it has to have both specific knowledge about the science domain and common sense knowledge. And with the help of these knowledge graphs, they're getting better and better at competing in this type of challenges. We'll look a bit more into this in the second half of the course. And finally, with more and more advanced natural language processing, you can also extract information directly from natural language text. So if you have information like here in a sentence, John was born in Liverpool, then you can have an NLP algorithm that identifies that there is a person in there, a location in there, and that there is a relation in there between John and the city. And then based on this analysis, you can extract a graph, either directly or you take an existing graph and add some information. So this doesn't work perfectly yet, but there are ways to at least semi-automatically create knowledge graphs. And now if you imagine how much text there is, how many documents, if you can make this all machine readable from natural language documents into a graph from, then again, you have a huge amount of knowledge that an AI can use. So this is roughly where we are in terms of research and development. So we now have significant knowledge graphs. We have some that are available online as open access. Companies like Google have their own bigger private knowledge graphs that they use in their products. But where there's still research that needs to be done is in automatically building and enriching these graphs. Building these graphs that we are looked at, there is a lot of work behind it. You'll see, because you'll have to do it in the course project. So you have to define the structure of the graph, the vocabulary. We'll talk about this next week. You have to take in some data online, like some documents, some databases, convert them into the graph. And then very often there are some mistakes that you have to fix from data import or data mapping and so on. So ideally, you could have an AI that can do this whole process by itself. It can help to construct, modify, and extend its own graph. And that, of course, would enable even more sophisticated AI applications. But this is sort of future research. What we do in this course is building on technology that's ready and available now. And you'll see there's already a lot you can do. So much for the first lecture on knowledge graphs. To give you something to read, so you have to read something about RDF. There is one document, this RDF primer, which is very nice. All the document links are here in the next page. So this primer here you can access online, and this is a very nice short introduction to RDF. You'll see we only covered half of it today. The next half, RDFS, will cover next week. But for a quick overview, this is a very good resource. But it's quite brief. It's really a primer. For a bit more, there are a couple of books, and this one I selected here. Developer's Guide to the Semantic Web, 2nd edition. This book you can access online, and you should be able to download the whole PDF of the book if you log in through the Concordia library. I hope nothing has changed. There have been a bit of changes to the online databases at Concordia library recently. If there is a problem, let me know in the forum, but you should be able to log into the library and download the whole PDF for the book. And in there, please read the first chapter. It's just an introduction. And chapter 2 is about RDF. You'll see it covers a bit more than what we have done in the lecture. So don't get confused if there is some additional material that we haven't covered, but it gives you a good overview on RDF. So additionally, well, this book, I think you cannot access at the moment because the library is closed. This is just for history of knowledge representation formats. There are some online resources for this as well. I think Wikipedia also has a page on knowledge representation formats. And there are also lots of videos on YouTube for graph databases. Note that graph databases are not necessarily an RDF format. So I'll also talk about this in a couple of weeks. But there are multiple ways of building graph databases, and not all of them are based on RDF. So don't get confused here either. I'll talk about these technical details also in a couple of weeks. But I think this is enough to keep you busy for a while, and the programming part we'll cover in the lab. So for now, make sure you post your worksheet results on the forum, and I will see you again next time. Bye-bye.